All right, this video will cover notes for section 4.3, systems of linear inequalities. A reminder of what inequalities are. The four types of inequalities you'll see are less than symbols, greater than symbols, less than or equal to symbols, or greater than or equal to symbols. If you have symbols that are less than or greater than, when you graph these inequalities, you should use a dashed line. You want to make a note of this information, when to use a dashed line and when to use a solid line. You use a solid line if the symbol is less than or equal to or greater than or equal to. So as we are making our graphs, we'll pay attention to our symbols to determine whether or not our graph should be dashed or solid. If you see the graph of y equals 2x in the first example, this is a standard equation. We will use the slope, which is m, and the y-intercept to graph this type of equation. Now we're starting with an equation because graphing an inequality is very similar to graphing an equation. What you would do is identify your m and your b. So this equation is already written in slope-intercept form. Remember, slope-intercept form is y equals mx plus b. So we identify m and b. Our m is the number that's in front of x. In this case, it's 2. So we write our slope as 2. And because 2 is a whole number, we want to make that whole number a fraction. That way we'll know our movement on the y-axis and on the x-axis. Do we move up, down, left, or right? And because we have a positive 2 in the numerator, we will move up 2 spaces. 1 in the denominator means we're going to move right 1 space. The y-intercept, there's no number after x, so our y-intercept is 0. This is where we start. Remember, you always start at your y-intercept. So we're going to go to 0 on the y-axis and plot the point. From 0, we're going to move up 2 spaces and write 1 to plot the second point. So up 2, 1, 2, write 1, boom, plot the second point, and then we connect those points to create the graph of the line, and you're done. Now, when we graph the inequality y greater than 2x, those same steps occur. Like we have y and the 2x on the right side. So we would find our slope and our y-intercept just like we would if this symbol were an equal sign. So our first step should be the same. Find m, find b, plot the points. So we plot 0, 0 again. We move up 1, 2, right 1, plot the second point. But because our symbol is greater than, we're going to connect those points using a dashed line instead of a solid line. The next step that we have to take is we have to shade either above the line or below the line. Now, we can look at this and say, hey, our y values that are greater are going to be above the line, on top of the line. But a surefire way to get the accurate section to shade is to use a test point. In this example, I used test point 1, 0. So this ordered pair, 1, 0. And you see how 1, 0 is below the line. You test this point by substituting 1 for x in the inequality and 0 for y in the inequality. And what you're testing for is to see if this makes a true statement. If the statement is true, then every other point down here with 1, 0 is going to be the solution. You would shade that section that contains 1, 0. If 1, 0 is not a solution to the inequality, you would shade opposite side of the line, the side that does not include 1, 0. So here we are testing the point. If we substitute 0 for y, we get is 0 greater than 2 times 1, substituting 1 for x. And is this a true statement? Is 0 greater than 2? No, that's not true. Because that's not true, you're not going to shade 1, 0 or any other point in that section. You're going to shade on the opposite side of the line. So those are the basic steps. Let's look at some other examples. Here we have graph this inequality less than or equal to 2x minus 1. First of all, notice our symbol is less than or equal to. So already we know we have to use a solid line for our graph. All right, so this should be a solid line. We start by identifying our slope and our y-intercept. Our slope is 2, right? And we'll write that 2 as a fraction by putting 2 over 1. So just like the previous example, we're going to move up 2 spaces and write 1 to get the second point. Our y-intercept is -1. We're going to start by plotting our y-intercept. So we'll go down on the y-axis here to -1, plot that point. And then we'll move up 1, 2, write 1 to get the second point. And remember, we're connecting these 2 points with a solid line. So we connect the 2 points with a solid line. And now we need to find a test point. Now, in the previous example, we tested 1, 0. Another easy point to test is 0, 0, the origin. As long as that point is not on the line, you can use it as a test point. So we're going to use 0 for x and 0 for y. 0, 0, test this point to see if when we substitute 0 for y and 0 for x, does this become a true inequality statement? And if so, we're going to shade that section that contains 0, 0. If not, we're going to shade opposite the section that contains 0, 0. Here we substitute 0 for x and 0 for y. We'll get is 0 equal to 2 times 0 minus 1. And 2 times 0 is just 0. Is 0 equal to -1? No, that's not a true statement. So this section that has 0, 0, we would not shade that section. We're going to shade the section that's opposite. Okay? And that symbol should be less than, I'm sorry. 0 is not less than or equal to -1. It's not less than or equal to -1. Therefore, we're shading opposite 0, 0. Now here in the second example, we're asked to graph 4x minus y less than 5. Our equation this time is not written in slope-intercept form. We don't have y by itself on the left side of this inequality. So we're first going to solve for y, okay? To do that, we're going to subtract 4x from both sides of this inequality. The 4x will cancel on the left. We bring down our -y. Now we want to look at that as being -1y. Bring down our less than symbol. And then on the right side, we have -4x plus 5. Next, we're going to divide both sides of this inequality by -1. The -1's on the left will cancel, leaving y. And remember, whenever you multiply or divide by a negative number, when you're working with inequalities, you have to reverse the symbol. So we change the symbol from less than to greater than. And over here on the right side, we're dividing both of these terms by -1. -4x divided by -1 gives us +4x. And 5 divided by -1 gives us -5. So now we have our slope. Our m is 4. We have our y-intercept is -5. Now, writing this slope as a fraction, we have +4. That means we're going to move up 4. That 4 in the numerator tells us to move up 4. And the 1 in the denominator tells us to move to the right 1 space. However, we start by plotting our y-intercept, which is -5. So here on our graph, on our coordinate plane, we're going to shift down on the y-axis 1, 2, 3, 4, 5, -5 right here. -5, plot the point. And then we're going to move up 4 spaces to the right 1 and plot the second point. So up 4, 1, 2, 3, 4, right 1, plot the second point right here in the fourth quadrant. And then we'll connect these points using a dotted line. We use a dotted line because our inequality symbol is less than. So we connect those points using a dotted line. And now we need to test the point to see whether we're going to shade above the line on the left or below the line on the right. And we chose 0, 0 as our test point. So if we substitute 0 for x and 0 for y, will we get a true inequality statement? Substituting 0 for x, we'll get 4 times 0 minus 0, substituting 0 for y. And we want to know if this is less than 5. So 4 times 0, that's just 0, minus 0. We want to know is 0 less than 5. And yes, that is true. 0 is less than 5. Therefore, you see this section where 0, 0 is listed. It's above the line on the left. We're going to shade everything on the left of this line, this dashed line. But this is our graph. All right, in the next example, we're told a point is a solution to a system of inequalities if it satisfies all of the inequalities in the system. Now, in the previous example, we graphed only one line. Now we're graphing a system, so we're graphing two lines. So we'll perform those same steps as if this were an equation. We determine whether we use a solid or a dashed line based on the symbol. This time we have greater than or equal to and greater than or equal to, so we should have two solid lines. And here we have y greater than or equal to -5. So let's imagine that were an equation. If that were y equal to -5 and x equal to 1, how would these lines be created? We go through the y-axis at -5. So that's what we're going to do. We're going to go on the y-axis to -5 right here. And the graph of this line is going to be a solid horizontal line that cuts through the y-axis at -5. So it'll be a solid line. And now we just need to determine whether we're going to shade above that line or below that line. So we're going to test the point. We're going to test 0, 0 again. Test 0 for x and 0 for y into this inequality statement. So 0 for y gives us 0. Is 0 greater than or equal to -5? Is this a true statement? Is 0 greater than or equal to -5? And that is true. Yes, it is. 0 is greater than -5. Therefore, you see this section that has 0, 0 above the line? We're going to shade everything above the line of y equals -5. Okay, so all of this stuff we're shaded. Now, when we go to graph our second inequality, we have x greater than or equal to 1. This graph is going to cut through the x-axis at 1. So on our x-axis here, we plot 1. And when we graph this line, we're going to draw that vertical line. It goes up and down through the x-axis at 1. After you get your line, your solid line, we're going to test that point 0, 0 again to see how we shade. Are we going to shade to the left of that line or the right of that line? So when we test 0, 0, we put 0 here for x, and we want to know if 0 is greater than or equal to 1. Is this a true statement? Is 0 greater than or equal to 1? No, that's not true. So you see that this section on the left side of the line where 0, 0 is, 0, 0 was not a solution, so we're going to shade on the opposite side. That's to the right of the line. Now the section that we shade 2 times, right here, in this first section up here, this is going to be the solution to the inequality because this is the section that we shaded twice. Remember, it was above the line of y greater than 5, or y greater than -5, and to the right of the line y greater than or equal to 1. So this section that shaded twice will be the solution to the system. And we'll look at one more section of examples. We have two other systems, y greater than x and y less than -x plus 6. Our first inequality, y greater than x, this is already written in slope-intercept form, y equals mx plus b. Let's identify our slope and our y-intercept. Our slope, the number that's in front of x, is 1. Okay, we want to see this as being 1x. So our slope is 1. As a fraction, we would write 1 over 1. That means up 1, right 1. And there's no number behind x, so our y-intercept is 0. We'll start at 0, plot that point, that y-intercept is 0. And then we'll go up 1, right 1 to get the second point. Now look at our symbol. We have greater than symbol, so we connected those points using a dashed line. And now we need to determine if we're going to shade above the line on the left or below the line on the right. We can't use 0, 0 as our test point because 0 is a part of the line. So we'll test using 1, 0. 1, 0, which is below the line. We're substituting 0 for y and 1 for x. So we want to know if 0 is greater than 1. No, that's not true. So 0 is not greater than 1. So we're going to shade to the opposite section. That'll be to the left side and above this line. Now that's our first graph, right? We've done the y greater than x. Now we need to look at the y less than negative x plus 6. Now, just like before, we're going to identify our slope and our y-intercept. Our slope is -1 this time, and our y-intercept is 6. So when we write that slope as a fraction, we'll get -1 over 1. That -1 tells us that we're going to shift down 1 space and then to the right 1 space. Starting with our y-intercept, we're going to plot 6. On the y-axis, we're going to go up 1, 2, 3, 4, 5, 6. Right here, plot the point. And then our slope tells us to move down 1, right 1, down 1, right 1, plot the second point. And we'll connect these points using a dashed line. Because look at our symbol, it's less than. So we're going to connect those points using the dashed line. And now we need to determine if we're going to shade beneath the line on the left or above the line on the right. We test 0, 0 because 0, 0 is not a part of the second line. When we test that point of 0, 0, 0 for x and 0 for y, we want to know if 0 is less than 0 plus 6. Is 0 less than 6? And it is. When we test 0, 0, we get a true statement. Therefore, we're going to shade everything below the line to the left, that section that contains 0, 0. Now notice the section that's shaded twice when we graph both lines. It's over here on the left side. That's the solution to our inequality, the system of inequalities. All right, the next example, we're asked to graph this system 3x plus 3y greater than or equal to 9. Solid line for both. We have greater than or equal to and less than or equal to. The second inequality, we have 4x minus 2y less than or equal to 8. First, we got to solve both of these inequalities for y. So we do that by subtracting 3x from both sides of the first inequality. And when we subtract 3x, they cancel on the left side, leaving 3y greater than or equal to negative 3x plus 9. And then we divide both sides of the inequality by 3. The 3's cancel on the left side, leaving y greater than or equal to, and on the right side, negative x, that's negative 3 divided by 3, that gives us negative 1x, okay? And 9 divided by 3 gives us 3. So our slope is -1. That means down 1, right 1. And our y-intercept is 3. So we're going to start with our y-intercept. Plot that point of 3 on the y-axis. We're going to go up to 3, 1, 2, 3, plot the point. And then we're going to move down 1, right 1 to get the second point. Remember, we're connecting those points with a solid line. So we connect the points using a solid line. And when we test 0, 0, 0, 0 is not a solution. So we shade above the line to the right, the section that does not contain 0, 0. For the second inequality, we have 4x minus 2y less than or equal to 8. So we're solving for y. First, we're going to subtract 4x from both sides of this inequality. And when we do that, the 4x's cancel on the left side, leaving negative 2y. Carry down our inequality symbol, less than or equal to. And on the right side, we have negative 4x plus 8. Now we're going to divide both sides of this inequality by negative 2. Now remember, whenever you multiply or divide by a negative number, you have to reverse that symbol. So we reverse the symbol. We changed it from less than or equal to greater than or equal to. The negative 2's cancel on the left, leaving y. And on the right side, negative 4 divided by negative 2 gives us positive 2x. And 8 divided by negative 2 gives us negative 4. So here's our slope 2. Our y-intercept is negative 4. We write that slope as a fraction by putting 2 over 1. That's a positive 2. So we're going to move up 2 spaces in the numerator and to the right 1 space. Now we're going to start by plotting our y-intercept, negative 4. We're going to go up here to our coordinate plane, shift down 1, 2, 3, 4 to -4, plot the point. Remember our slope was 2, 1, so we're going to move up 2, 1, 2, right 1, plot that point. And when we test this 0, 0, we see 0, 0 is not a solution again. So we shade beneath the line to the right. Now, which of these sections that we shade 2 times, that's this section here. This is where our solution will be. Our solution will lie. All right, when we test 0, 0 is less than or equal to 8, actually. So let's look at this again. All right, so for that first inequality, when we test 0, 0, let's go ahead and test the points. When we test 0, 0, we'll get 0 times 3, that's 0. 3 times 0, that's 0. Is 0 greater than or equal to 9? No. So 0 is not a solution to the first inequality. We shade it to the right, the section that did not have 0, 0. The second inequality, 0 minus 0, that's 4 times 0, 0, 2 times 0, 0. Is that less than or equal to 8? That is true. So therefore, we should shade the section that has 0, 0. All right, so for this second inequality, we should shade above the line to the right, okay? So this would not be the solution. It'll actually be this section in the upper right-hand section, because we're shading above the line and to the right of the line. So this would be our solution. All right, that's the last example from this section. We're going to stop here.